Hello students, today we will start combustion numerical on excess air. So this is the question. The boiler is fired with coal having the following percentage composition by weight, in which carbon is 74%, hydrogen 6.8, oxygen 13.2, nitrogen 2.1, sulfur 1% and rest is ash. Calculate the minimum quantity of air required for the complete combustion of 1 kg coal and the percentage composition by weight of the dry product of combustion if 20% excess air is supplied. Okay, so fuel sample quantity is given in the question is 1 kg. So in terms of 1 kg carbon is 74%. So we can write carbon is 740 gram, hydrogen is 68 gram, oxygen is 13.2% means 132 gram and sulfur is 10 gram. Okay, and remaining we can write nitrogen. So nitrogen is 21 gram. Okay, so first we have to write the oxidation reaction for all the components. So first we will calculate oxygen required for the carbon. So this is the reaction. Carbon reacting with oxygen and it is converting into carbon dioxide. So we can write here 12 part of carbon reacting with 32 part of oxygen and it is converting into 44 part of carbon dioxide. So this is the oxidation reaction for carbon. So we can write here oxygen required for the carbon is 32 divided by 12 into, in the question carbon given is 740 grams, so 740. So the value is 1973.33 gram of oxygen required for the carbon. This is the first equation. Like the same way we will calculate the oxygen required for the hydrogen. So hydrogen equation is hydrogen plus half oxygen, it is converting into H2O. So here we can write 2 part of hydrogen reacting with 16 part of oxygen and it is converting into 18 part of H2O. Okay, so for 1 part of hydrogen, oxygen required is 8 part. So in the question it is given 68 grams. So we can write 8 into 68 is equal to 544 gram of oxygen required for the hydrogen. The same next equation is for the sulfur. So sulfur plus oxygen, it is converting into sulfur dioxide. Okay, so we can write here 32 part of sulfur reacting with 32 part of oxygen and it is converting into 64 part of sulfur dioxide. So for one equivalent, the one equivalent of oxygen required. So in the question, sulfur given is 10 gram. So 10 gram of oxygen required for the sulfur. Now we will add all the components here, 1973.33 plus 544 plus 10. Now in the question, oxygen given is 13.2 or we can say 132 gram of oxygen we have already supplied with the fuel sample. So we have to subtract this value from the original value. So the minimum amount of oxygen required is 2395.33 or we can write 2.395 kg of oxygen required for the given fuel sample. Okay, so now these all values are given in gram or kilogram. So oxygen required for air required for the given oxygen is 2.395 into 100 by 23. This is by mass, and if the value is given in the volume, then you have to multiply by 100 by 21. This is in volume and this is in mass. So the amount of air supplied is 10.414 kg. This is the amount of air supplied, 10.414 kg. But in the question, it is given that we have supplied 20% excess air. Then we have to calculate the dry product weight. So first we will calculate what is the amount of air we have supplied. So we have supplied 20% excess air, then 10.414 kg is the original value of air supplied. So 10.414 into 120 by 100. So we have supplied 12.496 kg of air. This is the total air we have supplied in terms of 20% excess air. So now we have to calculate the dry product weight. So this is the component which has given carbon 740, hydrogen 68, oxygen 132, sulfur 10, and nitrogen is 2.1 gram. So we will calculate now product calculation. So same way we have to write the oxidation reaction for the carbon. So carbon is converting into carbon dioxide. So 12 part of carbon producing 44 part of carbon dioxide. So we can write calculation for the CO2, 44 divided by 12 into 740 carbon given in the equation. So 2713.33 gram of CO2 generated. Okay, next the dry product calculation, we will calculate the formation of sulfur dioxide. So sulfur is converting into sulfur dioxide, 32 part of sulfur producing 64 part of sulfur dioxide. So we can write 64 divided by 32 into sulfur given in the equation is 10 gram. So it is 20 gram of sulfur dioxide produced. Next, we will calculate nitrogen formation. Nitrogen will be 77% of total air. Total air supplied is 12.496 into 77% plus 21 gram nitrogen we have supplied with the fuel sample. So we will add that value also. So it is converting into 9638 gram of nitrogen formation. Next dry product calculation, we will calculate the excess oxygen which will not participate in the combustion reaction. So excess oxygen, for calculating excess oxygen, first we need to calculate the excess air. So 12.496 is the air supplied and actually air required is 10.414. So 2.082 kg excess air we have supplied. So it's 23 by 100% will be the oxygen. So oxygen is 0.47 kg. So this is the oxygen 0.47 kg, or we can write 478.86 gram of oxygen. So we will add all these four values: 2713.33, 20 gram of sulfur dioxide, 9638 gram of nitrogen, and 2.082 is air, and at that 23% of that one is 478.86 gram of oxygen. We will add all these values. So the total amount of dry product weight is 12850.19 gram. Okay, so now we'll calculate the percentage of the product. So percentage of the product, suppose if we want to calculate for the carbon dioxide, then the carbon dioxide generated is 2713.33 divided by total dry product into 100. So this is the percentage of carbon dioxide. So percentage of carbon dioxide is 21.11. Percentage of nitrogen is 75. Percentage of sulfur dioxide is 0.15, and percentage of oxygen is 478.86 divided by total dry product into 100, so 3.71. So like this way we have to calculate the total dry products and air and oxygen calculation. If in this question asks total amount of product produced, then we have to calculate the moisture calculation or H2 formation also in this question. Okay, bye bye students.